We welcome everyone. Today we'll be walking you through our project focused on analyzing user reviews from IMDb using a mix of NLP techniques. Our team is Dawar Jai, Jackson Smith, and Curtis Ray. I would call it the veterans team. We're composed of three veterans, the A team. We chose this dataset because it provides a rich source of textual opinions covering a wide range of emotions, genre, and audience and demographics. Our goal was to actually understand the sentiment and themes expressed in user reviews and evaluate how modern NLP tools like LDA can uncover patterns useful for business or apps developers. So for the agenda, we have the introduction to the dataset, research question, data processing, exploratory data analysis, topic modeling and evaluation, key insights, conclusion, and future work. Next slide. Introduction to the data set. We can go to the next slide so we can go to the overview. So for the overview, the data set we use contains actually 50,000 IMDb movie reviews, all text-based. Interestingly, we found that around 49,582 are unique, meaning only a small fraction, about 0.8%, actually duplicates, which is great and a great starting point for textual analysis. We use this data to explore what viewers are actually saying and how they feel, which can be very useful for movie producers, streaming platforms, or app developers aiming to enhance user engagement. Motivation wise, we wanted to actually go beyond actually sentiment scores and extract the key themes or topics people write about um, when reviewing films. Next slide. Research question. We started with three key research questions, which is what are the dominant topics like emerge from IMDb reviews? How do these topics correlate with sentiment? Can we build something practical like an app or dashboard to track audience sentiment by topic? These are important because they shift the focus from simple positive and negative labeling to why people feel the way they do, which is critical for studios and marketing teams. For example, knowing the acting and plot twist drive both strong praise and criticism could guide both production and promotion strategies. Next slide. I believe Curtis is doing analytic solution concept. You're on mute, Curtis.
Thanks. Sorry about that. So next we'll cover the analytic solution concept. So the aim of the app was to integrate topic modeling and sentiment analysis. The user input was auto-generated reviews from IMDM dataset. The output is an overarching sentiment of the entire corpus of the dataset. As they are mentioned, this dataset can really be useful for helping studios plan their streaming platforms and access to public market reception as far as what they're streaming, how they're streaming it, the timing, and then also the overarching concept and how it's actually received by those individuals that are viewing the content. Also, the product that we would like to produce would just be kind of a dashboard, kind of showing NLP driven results and review insights. So, the overarching result from this analysis is going to be the topics from most of the reviews, also the overarching sentiment for each of the reviews. Next, we'll jump into our pre-processing step. So with our pre-processing step, there was really structured into two parts, 2 to 3 parts. First was data cleansing, and then the actual pre-processing. So the steps that we had was kind of a circular, step-by-step process, which is depicted on the right-hand side here. What we ended up doing was we wanted to uh, show the text preparation pipeline on the right-hand side here. We first started by removing the HTML tags and punctuation for our data set. Then we created some code to push all of our casing, our alphabetical casing into lowercase and removed any unnecessary stop words. Next, we created a clean review column, which had all of our reviews there that was actually pre-processed, cleaned, and ready for analysis. Lastly, we did enhance reliability and input quality for modeling. This arrow actually reinforces that these operations form a iterative, self-reinforcing cycle that produces standardized modeling ready for text analysis. So at the bottom left here, what you'll see is the top 20 most frequent words that were used in this corpus. So you can see at the top, it was the highest, followed by good, view, even, and up. And so these words emerged as the most common tokens, illustrating how preprocessing yields a clear view of the dominant themes of the data. Together, these elements communicate how raw HTML tagged reviews were systematically transformed into high quality, analyzable text in the clean review column, and why it matters that we cleaned it prior to actually starting our analysis. So next we'll run into the data analysis, in particular the data validation step. So some of the high level things that we covered here was how many reviews did we have, how many were positive and negative, and then also do they have an equivalent size. So as you can see on the upper right hand corner, it was actually kind of shocking to see that we had almost an even split on the positive and negative sentiment across our entire corpus. We had roughly 25,000 views confirming the balance. We had a very balanced data set. On the bottom left, the plot here is the review links for word count. And it shows the distribution of negative reviews, which are in red, and the positive reviews, which are in teal. Both distributions peak around shorter views, which are between right around 500 to 1,000 words. And the negative curve has a slightly longer tail, indicating more, the longer the review, the more likely, or the longer the review, the more likely it would be perceived as a negative overarching sentiment. Together, these two elements demonstrate that you have a sizable, we had a very sizable and well-balanced sentiment data set that highlighted subtle differences in the review links. And so, yep, that's what we have for this slide. Next, we have the data analysis techniques.
Then I'll take it from here. Everybody, Jackson Smith. At this point, we're going to kind of transition into the actual techniques used. Kind of highlight some of the actual functions within the text analytics domain, and then kind of highlight some of the bigger takeaways from that. So kind of starting at the top here, using count vectorization and TF-IDF vectorizer. These are both Python packages, functions, used through Google Colab and Spider, if there's any interest in replication. But the reason we use these two and the differences between, so TF-IDF, the second TF-IDF vectorizer, captures the importance of it, whereas count vectorization really just hits on the frequency. So that's kind of one of like the bigger splits between those two. Kind of why using both of them in concert is more of the preferred technique within the text analytics domain. For the generated the BOW bag of words and the TF-IDF matrices, again, these are just to highlight the importance of the words themselves and the frequency of occurrence across. This is really used to kind of pull out a lot of the sentiment, kind of understand what is being discussed in these reviews, and kind of what the drivers are for the ultimate sentiment. We trained this, or using these results, we trained a latent derelict allocation model, it's that LDA, with 5 topics to uncover the themes across the reviews. Examining most the most significant words in each of these 5 topic buckets. Each review was tagged with the dominant topic, kind of letting us or allowing us the flexibility to identify and track trends across as we got further into the data set itself. We chose LDA over the other models for the interpretability and topic discovery components of the model itself. And using this, we're able to identify what the sentiment was, and then use the known sentiment to tag it to the review itself, and ultimately understand our final accuracy. After kind of going through this portion, we did the sentiment analysis with Vader. If we can go to the next slide, please. Next slide, please. Thank you. So the sentiment analysis with Vader applied NLTK sentiment intensity analyzer. NLTK is Python package, again, for just replication interest. Generated the sentiment scores for each review, classified the sentiment as positive, negative, or neutral, and then aggregated the sentiment by topic for additional insight. So the sentiment analyzer, sentiment intensity analyzer, provides an overall Vader technique, applies a sentiment score rating from -1 to +1. So one of the kind of the pros and cons of this technique, we'll get into the results here in the next slide, but it'll show you what the ultimate bucket review score was, whether it's like more negative, more positive, but it doesn't necessarily provide a representation of the standard deviation or the variance within that bucket. So it is one of the limitations of the model itself. So just want to highlight that one. So if there as an area for further development, should we continue to go down the rabbit hole of this data set. Ultimately, this type of analysis can help businesses and studios anticipate public reaction, namely and specifically looking at like sequels to initial showings, right? So if you have like Fast and Furious 945, well, Fast and Furious 944 had a pretty negative review, so you would generally expect the 45 to have a similarly negative review. Whereas like Toy Story 1 had very positive, and Toy Story 2 you would expect to maintain that same positive score. But again, want to really highlight and dig into the clarification point there. The standard deviation is not represented. So if the public opinion is across the board, we're not really going to get a great picture of that or the variance. So we'll give you a neutral score, but you won't actually see like what the variance looked like. So for our results and conclusion, this shows the average the topic and the overall sentiment distribution. Again, that 0 bucket and that 0 score does not necessarily mean all of the topics and all the reviews were neutral, but it does mean that like overall in that bucket, that was a neutral scoring bucket. Topics 1, 2, 3, 4 all had very high scores. And we can see that overall distribution represented in the lower graph there, the number of reviews, positive, negative, and neutral. It was interesting to see compare this to the previous classification of an equal distribution of both positive and negative, where we identified having significantly higher or significantly more positive. Further analysis and further text analytic packages can be used to identify where that difference is coming from, why it exists at all, and kind of ways to mitigate or adjust the algorithms accordingly. If we can go to the next slide, please. So the recommendations, so embed LDA and Vader for live feedback monitoring, using GPT-4 to auto-summarize review clusters by topic, and integrating generative AI to generate marketing messaging or auto-tag content. Additionally, GPT-4 can be used to view the screenings of the movies or series or episodes as they're being developed, and do it iteratively, programmatically, and ultimately have a GPT evaluation of a model before putting it out into a streaming platform or a viewing platform. Next slide. So just to kind of highlight some of the individual contributions, we see here, it took care of the cleaning, pre-processing sentiment. Ernest drove the